A number of you have expressed difficulty with lesson 4, which deals with interval notation and linear inequalities. So I've pulled some of the questions from the lesson 4 homework 1 from Newton, and I'm going to kind of walk through them together and point out some things. I'm going to show you how to write the answer not only on a number line but also in interval notation. So the first question says the set of all numbers less than or equal to -6 or greater than or equal to -2. And so they want you to take and basically show this particular expression on the number line. So it may help you, first of all, to think about what the words mean. So you have the phrase less than or equal. And so symbol wise, that would be the little v that points to the left, less than points to the left, and equal, when it says equal, you put like the little 1/2 of an equal sign there. So you would have some number less than or equal to -6. And then they have the key word here as or you want a number that is greater than or equal to -2. So you want greater than, that's going to be the V that points to the right, and then or equal, again, you have 1/2 of the equal sign to -2. So you have some number that is greater than or equal to -2. Okay, so if we think about what this would look like on a number line, okay, I'm going to rough sketch it here. Okay, whenever you have equal in terms of drawing things on a number line, we use a colored in dot to indicate that we can use that number. So for x is less than or equal to -6, I'm going to draw a circle at -6 and I'm going to color it in because it is equal. When it's equal, that indicates I can use it. I kind of think about this sort of like a manhole cover, and so I could actually stand on this point so I can use it. And then less than goes to the left. The other half of the problem is we have greater than or equal to -2. So again, I'm going to draw a circle at -2, and again, I'm going to color it in because it is equal to, so I can use it, and greater than is going to go to the right. So there you have the graph or the number line for the set of numbers less than or equal to -6 or greater than or equal to -2. If I were going to write this in interval notation, you always read your number line. You always want to start at the left and read to the right, just like you typically would read a page in a book. So if I start at the left, even though I can't really see it, here on the left, this is going to continue on forever and ever and ever and ever. And mathematically, the way we represent that is we use negative infinity. So I would start way over here on the left at negative infinity, which always gets a parenthesis. And then we can use all the numbers until we get to -6, and we can include -6, and we show that in interval notation by using the square bracket. Whenever you have an equal to or a colored in dot, you're going to use the square bracket. Or, the symbol for or is this funky looking U. Okay, it's from set theory. It means or. And then we skip all these numbers from -6, so we can't use -5, -4, -3, or anything in between. We can then pick back up at -2, and it is again equal, so we use a bracket. And then we keep going forever and ever and ever and ever and ever and ever to the right. So that goes to positive infinity. Always write your interval, the smallest number first, comma, the largest number. Okay, so there's interval notation. Right? The next one says the set of all numbers greater than or equal to 5. Okay, so if I'm thinking about those symbols, I would think about greater than or equal to 5. Okay, so I've got some number. The key word here is and that makes a difference. Okay, because that means when you have the and, that means you have to meet both conditions that are given here. So in this case, I would have to meet the condition that it's greater than or equal to 5, and at the same time, simultaneously, it has to be less than or equal to 7. So we would have less than, which points to the left, or equal to 7. Okay, so this is an and. Now, let's visualize this, and that may help you see a little bit more what's going on. Okay, so we have, let me draw my number line here. Okay, here's my number line. So we start at greater than or equal to 5. So we're going to put a circle at 5. And again, it can be colored in because it is greater than, or because it is equal to. We're going to go greater than, which points to the right. Then we have less than or equal to 7. So we're going to have 7. And again, it's equal to, so it can be colored in. We can use it. And we want to be less than that. But here again, what we're looking for in this problem is the and where both conditions are met. So both conditions are met if I look at where I have kind of the double colors between 5 and 7. And I can use 5 and I can use 7 because it's equal to. So really what you end up with is this little piece between 5 and 7. Okay. Interval wise, we start at 5. We're going to end at 7. Again, we work left to right. And we can use both of them because it's equal. So we put brackets on the end to ensure that that's how we indicate that we're going to use them. All right, then let's move on to linear inequality. Okay, this is basically similar to an equation with the difference that instead of an equal sign, you have greater than or equal to. So we solve it similar to solving an equation. We're going to get all the x's together, and I typically put the x's together on the left. So I'm going to subtract x from either side. So I have 3x plus 15 is greater than or equal to 6. Then I'm going to get all the numbers together on the right side. So I'm going to subtract 15 from either side. So I have 3x is greater than or equal to negative 9. Then I'm going to divide both sides by positive 3. Because I'm dividing by positive 3, I don't have to worry about flipping or inverting the symbol. So x is greater than or equal to negative 3. So if I think about what that would look like on a number line, okay, again, I notice at this point that it is equal to, so I know that I'm going to have a solid or a colored in dot at negative 3, and I want to be greater than that and greater than. Notice how it points to the right, and it's actually going to keep going forever and ever and ever in that direction. So there's you're basically going to keep going out to infinity. Okay, so we start at -3, which is a usable point. It's a colored in dot, so we use a bracket in terms of the interval, and we keep going to positive infinity. Okay, so there you have the solution, you have the graph, and you have the interval notation. All right, continuing on with the next one. Again, you have -10x plus 12 is greater than -8x plus 14. So I'm going to add 8x to either side. Do it just like you're solving an equation. You're going to get all the x's together and all the numbers together. So I have -2x plus 12 is greater than 14. Then I'm going to subtract 12 from either side. So I have -2x is greater than +2. I'm then going to divide both sides by -2. And in this case, because I'm dividing by a negative, I have to flip the inequality symbol so it becomes less than -1. Okay, so if I think about the number line, okay, in this case, notice I don't have an equal to, so I cannot use the value of -1. And the way we represent that on a number line is we just draw a circle, and it's not colored in. It's like it's an open hole, and you would fall through it if you tried to use that particular value. And we want to be less than, which goes to the left. It's going to keep going to negative infinity because I'm headed to the left in the negative direction. Now, it gets a little tricky probably to write the interval again, because remember, you want to start at the left. So if I start at the left, I'm going to actually be starting way out at negative infinity, and I can come all the way up to the value of -1. It's not usable, so we use a parenthesis to show that we could not actually include that particular value. And finally, one more, and as we do this one, I'm hopefully going to be able to show you how to use the number line tool within Newton. Some of you seem to struggle with that. This particular problem is what I would call a between, because you have a problem kind of at the beginning. You have 7x plus 5 is less than 10x minus 7. But then you also have a second problem if you consider the middle and the second piece. So you have 10x minus 7 is less than 7x plus 8. So it's like two problems in one, and it's just a mathematical way, shorthand way to write the problem. So again, we use the same techniques that we've been using. We solve for x in both pieces. So I'm going to subtract 10x, subtract 10x. So I have -3x plus 5 is less than -7. I'm then going to subtract 5, subtract 5. So I have -3x is less than -12. And then I'm going to divide both sides by -3. And again, because I'm dividing by negative, I have to invert my inequality. So it becomes x is greater than 4. All right, then I go and I'm going to do the other side. Okay, so if I come back and I start over with the second problem, I'm going to subtract 7x from either side. So I have 3x minus 7 is less than 8. I'm going to add 7. So I have 3x is less than 15. And finally, I'm going to divide both sides by 3. So x is less than 5. Okay, so there's your answer. Okay, so this is sort of like, if you go back to think about the words, we're saying that 7x plus 5 is less than 10x minus 7, and, this is an and, 10x minus 7 is less than 7x plus 8. So if we think about what this will be on the number line, again, because this is and, we're saying x is greater than 4 and less than 5. And if you think about what that would look like on a number line, okay, so we want to be greater than 4, okay, but the 4 is not included, it's not equal to, so you're going to have an open circle and be greater than. Then you're going to have less than 5. Again, the 5 is not included, so you're going to have an open circle and you're going to be less than. But again, because this is an and, we're looking for kind of that overlap. So the overlap occurs basically between 4 and 5. Okay, so you're going to have an open circle on either end. Basically, looks like almost like a little pair of eyeglasses. Okay, so let me switch over to the Newton and see if I can show you how to use the number line, since so many of you had difficulty with that. Okay, so here was our question, and we've determined that our solution is between 4 and 5. Okay, so the first thing I'm going to do is I'm going to click on the little blue diamond that's on -5, and I want to move it to my solution point of 4. And then the other one I want to be on 5, which is at 5. Okay, so I've got my two endpoints at 4 and 5. Okay, and all I did was click on it. See how the little arrow comes up, and you can move it back and forth across the number line as you need to. Okay, then I have to decide, do I want an open dot or do I want a closed dot or an open dot? Well, we noted that in this case, neither one of the endpoints are included, so we need open dots. So we would click on the little orange circle and just scroll it down so that in the middle here, between the kind of these dots here, right here in the middle, you see, okay, you can see right here is the number line, and it should look like what's on your test paper or what's on your scratch paper. And if we want to verify that, I can submit. Okay, I can submit, and it tells me that, we got the right answer. Okay, so don't overthink it, guys. It's really simple. You just click and move, click and move. Okay, all right. Hopefully that'll help you as you prepare for your midterm exam, because you will see some examples or some problems similar to these inequalities on the midterm.